Hi there. This is a review of Work, Energy, and Power, Unit 4 of AP Physics 1. So what background information do you need to know? Well, here are the equations that you need to know. So work equals force times distance times cosine of the angle. And that is measured in joules. So what the cosine of the angle is not always there because the angle is 0. Cosine of 0 is 1. So force times distance times 1, that's just force times distance. So that's why sometimes that's not there, because there's only if there's no incline. Power is work divided by time, and it's in watts. And then we have the two energies that we learn about are kinetic energy, which is 1/2 mv squared. And this is really just linear kinetic energy. And then that's measured in joules as well, just like work, because work is the change in energy. That's very important to know. And then potential energy due to gravity is mgh, or sometimes you see delta y, but that's the same thing as h. And the initial energy equals final energy. That's not always the case, but when there's thermal energy that it can be converted to, that's not always the case. So just keep that in mind. And if the force is negative, the work is negative. So sometimes the work is negative, just so you know. Okay, so we look here for a pendulum. Speed is 0 when it's up there. Kinetic energy is 0 because of that also, because the equation for kinetic energy has V in it. If V is 0, then it makes the whole thing 0. And so height is max, and so is potential energy if height is max. Because potential energy due to gravity is mgh. If you have a maximum height, you also have a maximum potential energy. And then total energy is constant. There's none that's dissipated through that. And that's the same for B, both of those. And then it's the opposite for I don't know, it looks like something's got erased here. It's weird. The speed is maximum at the bottom, and so is kinetic energy because of that. And the height is 0, so the potential energy is 0, and the total energy is still constant. So for this, you use the area under the curve of force times distance graph to determine the work. Think about it. Force times distance, that means force on the y, distance on the x. If you want to try to find work is force times distance, and the slope would be force divided by distance. So the area under the curve would be force times distance. All right, and then this problem, we're trying to find, let me go ahead and erase this, because I already tried to make this video once, but it just accidentally did the wrong thing. So there's a rubber ball that's dropped straight down from a height. So let's just see that. There's a height of 2 meters. It's dropped, and then it bounces, and it's saying, what is the new height? Okay, that's what we're trying to find. So the eraser's not working, that's why I have to use this. At least it wasn't working earlier. So what equations can we use? Well, at first you might think, okay, initial energy equals final energy. But that's what I was talking about, where that's not always true, because it's converted to thermal, the total mechanical energy is not constant this time. But what we do know is that if we're trying to find a final height and we know an initial height, then we can use change in height. What equation has that? Well, that's change in potential energy. And so that means this is change in energy. But we can set that equal to the energy lost. So energy lost, we can just call that T for thermal. That's what we need to use because we're finding a difference in height, and if we want to find a new height, that's what we do. So the thermal energy is 0.05 joules. Mass is 2. Gravity is 2. And then for change in, you do final minus initial. Final, we don't know. Initial was 2. So now we're going to try to find this. So we would do 0.05 divided by 20 if you multiply the 2 times 10. And that is 0.0025 equals h minus 2. So you add 2. So the new height is 2.0025 joules. So that one was a little bit tricky, but you just have to know that when you're finding change in, you'll use the delta, and you set that equal to energy lost. Okay, let's see. I'm not going to do every single one of these as usual, but let's see. All right, this one. 2 identical masses are on inclines A and B with different heights and different lengths. The coefficient of kinetic energy, ooh, that's not good, is 0.38. Compare the change in kinetic energy and change in potential energy for both. So we have the change in kinetic energy for A, and we have the change in kinetic energy for B. We have the change in potential energy for A, and we have the change in potential energy for B. And we're going to do greater than, less than, equal to. So how do we figure this out? Well, let's start out with the potential energy is a little bit easier. So what is potential energy? It is mgh. And we have to find the differences between those 3 things. The masses are the same, the gravity is the same, and the heights are the same. All things are the same, so the potential energies are the same. Now, what about the kinetic energy? All right, the masses are the same, but not letting me draw. But are the velocities the same? No, because there is different length, and we know by our kinematic equations that if you have a different distance, there's going to be a different velocity. But how do you know which one's going to be greater than the other? Well, our equation for velocity no, we can't use that one. Well, we don't necessarily have to look at the velocities. There's another way we can do it. This is probably the easier way. So initial energy equals final energy. Initial energy for A, well, for both of them, they start out with potential energy, and they end up with kinetic energy, and they have thermal energy as well, because there's friction. So the kinetic energy is going to be equal to this. So the more thermal energy, so if thermal energy goes up, the kinetic energy goes down because C, it's subtracted. So how do you know which one has more thermal energy? It's the one that's longer, because it's on there for a longer amount, more energy will be lost. So that means that A has more kinetic energy because it's shorter. So that's just something that you got to think about. Okay. All right, let's see which one. All right, let's look at number 6. A 6 kg block, let's go ahead and write that. Slides from point A to point B. After it passes B, oh, of course, there's a friction force. See, they try to do the dumb things like that. So let's just make this a little scratchy looking because there's friction. But there's no friction for that part. So right here, you can say the coefficient of kinetic energy, or sorry, coefficient of friction is 0, but here it is not 0. So, and it causes it to stop 2.5 meters from B. So this is where it stops. All right. What is the coefficient of kinetic energy? Oh, what? Well, we got to think about it. Okay. This is a tough one. Hey, this is a tough one. All right. Then this is the kind that you might see on your exam. So what do we do? What the heck? Well, when in doubt, remember KFES. It is crucial and it makes things seem a lot simpler. So what do we know? Well, I just drew on here what we knew. What are we trying to find? We're trying to find this guy. And now we need to, next step is equations. And that can be the hardest one. I mean, KF, they're what's there, and solving algebra it can be simple, but so we need to think what equations have that in it that we know. Well, you might say, okay, well, I know the force of friction equals mu times the normal force. That equation has mu in it. All right. Well, do we know the friction force? No. Do we know the normal force? No. But how do we find those? Well, we know that the sum of the forces equals mass times acceleration. Well, do we know mass? Well, yeah, we do. But do we know acceleration? Oh, of course, we don't. So we would have to use a kinematic equation like this one, because we don't know time, so it's got to be the one that doesn't have time. All right, now that we know this, do we know distance? Yeah. But do we know velocity? Oh, no. And so you might just be kind of annoyed because you're like, great, don't know anything. Well, that's just what they're like sometimes. You have to connect so many different things. And that's why the equation part is important. So how do we find velocity? Well, we can use what we know, that kinetic energy equals mass times velocity squared. Oh, yeah. But do we know kinetic energy? No, we don't. So still can't use only those. What else do we know? Well, we know that initial energy equals final energy. So we know that the potential energy equals the final kinetic energy. But do we know potential energy? No, we don't. But we know that it equals mass times gravity times height. Do we know mass? Yes. Do we know height? Yes. Do we know gravity? Yes. So finally, we have all the equations that we can use. That is so dumb. You have to use 6. That's just how it is. So sometimes before you solve, you might want to think about what steps you're going to do, because this is a lot of steps. First, we need to find the potential energy. Then we need to find the kinetic energy. Once we know that, then we can find the velocity. When we know the velocity, then we can find acceleration. When we know the acceleration, we can find the forces. When we know the forces, we can find mu. And that's what we're trying to find. So there you go, 6 stupid steps that we have to do. That is so annoying, isn't it? Well, there you go. Why'd you sign up for this class? You had to know that there was going to be annoying things. All right. So we said the first thing we're trying to do is we're trying to find potential energy. Potential energy equals mass times gravity times height. What was our mass? It was 6. What was our gravity? It's 10 as usual. What was our height? It was 1. So potential energy equals 60 joules. Pretty simple. All right. What's the next thing? Kinetic energy. Okay. We need to find that by knowing that the initial potential energy equals the final kinetic energy. The initial potential energy equals 60 joules. And kinetic energy, well, so that means that's the kinetic energy. So, all right. And so the velocity, now we need to find that. Kinetic energy equals 1/2 mv squared. Okay. Our mass was 6. Oh, wait. Our kinetic energy was 60 joules. Our mass was 6. Our velocity was what we didn't know. So that would give us 20 equals v squared. So the velocity equals approximately 4.4 meters per second. Right? Then what do we need to find? Acceleration. We were going to use a kinematic equation, remember? All right. The final velocity, well, remember it came to a stop. So that's 0. The velocity we just found was 4.4. Don't forget your squared. 2, we didn't know the A. And this one's a little bit tricky. What is the distance? Well, it's distance. We're trying to find it for the friction, and there's only friction for that section, which is 2.5 meters. So don't try to think that it's the whole thing. It's only that part. Okay. And when you solve for A, you would get that A is 3.81 meters per second squared. All right. Now, what was the next thing after that? All right, we need to find our friction force. Or not necessarily just our friction force, but okay. Well, yeah, we can just use the friction force because by doing that, we would know the normal force. So the friction force, which is the only force that there is at that point, and the x direction, is mass times acceleration. So mass 6, acceleration 3.81. The friction force is 22.86 newtons. Now we know that the friction force equals this, or mu mg cosine theta. Well, there's no angle once it's at the bottom, so that is 0, and cosine of 0 is 1. So goodbye. Now we just have this. So that rearranging this, what we just found, that friction force is mu mg, mu equals friction force divided by mg. Friction force was 22.86, and the mass was 6, gravity is 10, and finally we get our answer, 0.39, and there's no units. So it is about 0.4 newtons. Well, it's putting newtons on. Oh wait, yeah, the newtons is not the unit, sorry. Okay. So as you can see, sometimes they can be pretty tricky. You have to do a lot of steps, but just do what I did. Think of all the equations you can use. If you're like, great, I don't know that, well, think of another equation to where you could find that out. All right, then, well, I wanted there to be there's not a problem on this thing for work, like actually using the work equation. There's just been energy. So let me try to find one real quick. I'll just scroll down to the bottom right here. Scroll up. Oh, okay. Just have to wait a second. I don't think I can pause the recording. Oh, I can. Okay, so pausing. Okay, so I have this here now. So a 20 kg box is pushed by a 100 Newton force 30 degrees over the horizontal to the horizontal over 10 meters. Coefficient of friction is 0.5. So let's see, write down what we know. Mass 20 kg, kilograms. Force, and that would be the force applied. So say FP is 100 newtons. The angle is 30 degrees. The distance, we just do D, is 10 meters. Now let's draw a picture of what it's like. So it's not on a ramp, don't get confused. And really we'll just do a free body diagram. So the dot is the box. Always have a gravity force down. Always have normal force up with the surface, but surface is directly up because it's not on an incline. There is friction force to the left. Well, it doesn't say that it's applied to the right, but we can just assume that in this case. And then the distance, or sorry, there's also a applied force, but it's 30 degrees above the horizontal. So the angle is 30 degrees. That makes. So let's see. Oh, I forgot to write on this. All right. So what is the work done by the normal force? Well, for one thing, how do you find work again? It is force times distance. Oh, times cosine of angle. So the force, what is the normal force? Normal force is the normal force is the mass times gravity times the distance times the cosine of the angle. What is the mass? Mass is 20. Gravity is 10. What's the distance? Oh, 10. What is the angle? Well, it's always the angle with the surface at which the force is applied. That is a 90-degree angle with the surface. So the angle is 90. But if you know, cosine of 90 is 0. So that means the whole entire thing is 0. So the work done by the normal force is 0 joules is the unit. And it's the exact same for gravity, because it's the same equation just in a different direction. So it would be negative if there actually was something, but there's not. So the work done by gravity is also 0 joules. And when it's on an incline, that's different because you have to consider the angle based on gravity. So just remember that. All right, the work done by the applied force, that is just whatever force there is times the distance times the cosine of the angle. So force, it said the force was 100 newtons. The distance, it said, was 10 meters. The cosine, and what angle was it? The angle was 30. So we have to do cosine of 30. And we solve that, you get 866 joules. Okay, so that's simple enough. Now, what about the work done by friction? That is friction force times distance times cosine of angle. The angle is 0, so cosine of 0 is 1. So really it's just FFD. Friction force is mu mg cosine theta, but don't need to put that because there is no angle for the friction force, at least. So it's this. So that mu is 0.5, mass is 20, gravity is 10, distance is 10. So the work for friction is, oh, sorry, something very important, negative, because the friction force is negative. I already said that at the beginning of the video. That is negative 750 Newton meters. Well, oh, sorry, I don't know what I was thinking. That is not what the friction force is. Let's start this over. So it's true that it is FFD, but how do we find what the friction force is? We have to do Newton's law, which is so, and we'll do the x direction. So we have a positive this and a negative this. hang on a second. Okay, sorry. So it would be we need to do the friction force minus the x component of the applied force, because you can't just have just the friction force, because remember the friction force is based on the normal force. And the normal force is mg, but not just mg, because well, the normal force is, but not the friction force, because the applied force is at an angle, kind of. But for this, you would use sine as what you do for the angle, because this is the friction, or the applied force, this is fpx, and to the angle, this is adjacent. Adjacent means sine. Okay, so, or adjacent does not mean sine. Okay, let me start over. You would use sine because, okay, I got this backwards, sorry. You have to subtract it from the FPY, and that's because the friction force is mu, and let me just erase this off. So the friction force is u Fn. But how do we find Fn? It's going to be minus all of the other, or, well, we'll have to subtract the other, it's equal to the other forces that are in the y direction, which is Fg, but also Fpy. And the Mg is you have to do minus Fpy. Yeah, because that's the other y direction force. And that is sine because opposite is sine, not adjacent. So now we go back to this, and so we have to do the mu and then times the normal force, which is the gravity force minus Fpy. So you have to do the Fp with the sine component of it. And once you plugged in all those numbers, you would get that it is negative 750 joules. So sorry that I got mixed up on that one, but it's because at first I was thinking like I was doing the friction force wrong. It's the normal force, because you have to use the normal force. And to get it, you subtract other things using Newton's law. So what is the net force? Or sorry, the net work. The net work is when you combine all the different works that there are. So we had, and this is negative, by the way, because it's friction to the left, because it's opposing the motion, the other one. So we had 0 for normal, 0 for gravity, 866 for applied, and then minus, we have to do minus 750 for the friction. So the net force or net work is 116. 116. Wait, that's not right. 866 minus 7. Oh wait, yeah, that is correct. Okay, and that is joules. So that is it for the work unit. And so something to keep in mind, this is why I wanted to add this problem in here, because things get a little bit confusing. But just remember, well, for the harder ones, it may take more than one step. So write out the steps. Remember what I did for that one, the 6 steps. And for the other things, remember to use Newton's second law, which is the force equals ma, sum of the forces. Sum of the forces equals ma for work of a specific force. Sign is if the thing you're trying to find, the component is opposite to the actual line, and cosine is if it's adjacent. And yeah, that's about it. So thank you for watching this video. Sorry for the confusion. I don't know, I think I just got mixed up with things, and that can happen, but that's why it's important to know these things, which I should have thought of myself. But anyways, thank you for watching, and stay tuned for the next videos.